Problem number 33. And this is the function of three variables we're being asked about. First thing, we need directional derivative in the direction. So d sub u of f at point 1, 1, 1. In the direction, in the same directions, v is 1, negative 2, 2. Okay, so what do we have to do here? One thing is, well, we know we're going to need the gradient. The gradient of f is going to be the x partial derivative here is z plus y. The y partial derivative is 3y squared z cubed plus x. And the z partial derivative x plus 3y cubed z squared. But we don't just need the gradient of f, we need the gradient of f at the point P, 1, 1, 1. Plugging in 1, 1, 1 will give us 1 plus 1 is 2. 3 times 1 plus 1 is 4. 1 plus 3 times 1 is 4. So there is our gradient. Okay, the second thing that we need to do here, we need to make sure we have the direction. So v is 1, negative 2, 2, but we need a unit vector. We need a unit vector. The magnitude of v here is 3. So u is 1/3 times 1, negative 2, and 2. It's 1/3, negative 2/3, and 2/3. So then how do we get the directional derivative of f at the point P? It's going to be, we take the dot product of the gradient, 2, 4, 4, with the unit vector pointing in that direction. 1/3, negative 2/3, 2/3. And so we end up with 2/3 minus 8/3 plus 8/3. And this is equal to 2/3. So there's a directional derivative in the direction of that vector. For part B, it says find a unit vector u pointing in the direction in which f decreases most rapidly at 1, 1, 1. So the first thing to realize here is that the gradient of f at 1, 1, 1 points in direction of greatest increased. And so how do we get a vector going in the direction of greatest decrease? We just multiply the gradient by negative 1. So a first answer to part B is the negative of the gradient here, negative 2, negative 4, negative 4. Now the catch is, if we read the problem carefully, it says we're being asked for a unit vector. And so we need to turn this into a unit vector. What is the magnitude of, let's call this W. The magnitude of W is going to be negative 2 squared plus negative 4 squared plus negative 4 squared. Take the square root of that. And so this is 4 plus 16 plus 16 under the square root. That is 36. The square root of 36 is 6. So what is our final answer? Divide this by 6. Okay, so negative 1/3, 2/3, 2/3 points in the direction in which f decreases most rapidly there. Okay, and then part C says we have f of x, y, z is equal to 3, this level surface here. Find equation for the tangent plane to this level surface at the point 1, 1, 1. To find equation of a plane, we need a point 1, 1, 1, and we need a normal vector. And for the normal vector, we're going to use the gradient. The gradient is perpendicular to the surface, so we can use the normal vector here. By the way, we can scale it. Negative 2, negative 4, negative 4 also works. Negative 1/3, 2/3, 2/3 also works here. but I'll just use this one. 2 times x minus 1, 2 times x minus 1, plus 4 times y minus 1, plus 4 times z minus 1 is equal to 0. And so there's our tangent plane.